everyone, welcome to my channel. If you love 3D printing, electronics and DIY tech project, you are in the right place. Today we are starting an exciting journey by reviving an old 3D printer with a simple but effective upgrade. Stick around if you want to learn about hardware mods, firmware updates and calibration tips to get the best out of your printer. Let's get started. I was organizing my lab when I found 3 old printers collecting dust. A G-Tech i3 Pro B Prusa clone heavily modded, a G-Tech i3 Pro C like the Pro B but a dual color extruder, never really worked that well, and a G-Tech A20M, our focus today, similar to the Creality Ender 3. The A20M is a dual color extruder constantly clogged and needs too much maintenance and attention to work. So instead of fighting with it, I'm upgrading it to a single material, high performance extruder and a good quality hot end setup. I choose this A20 because it has so much in common with the Creality Ender 3, and considering how many Ender 3 are there, maybe this video could be a guide for the Ender 3 owners too. In a second video, part of this tutorial, I will be installing Clipper on Raspberry Pi 3 and connect the two together. Let's see how much we can gain in speed and quality. Let's get into it. First, we need to remove the old dual extruder tool head. We will save any useful parts, but most of them will be replaced. For this project, I will use the Dragon Burner tool head. This is an open source project, part of a bigger project called Boron. I found 3D printables, STL files for the Creality Ender 3, but the A20 has a small differences. So I designed a custom mounting brackets to fit Dragon Burner hot end, and I modified the front of the tool head to fit the Pinda, the bed leveling sensor which we will use. For this update, I'm using a 3D printer parts from my spares and old material. We will use a hot end, E3D version 6, an extruder, LDO motors, Orbiter version 2, a bed leveling probe, Pinda sensor, which is the same that Prusa MK3 uses. I will drop the link in the description for the Dragon Burner GitHub repository for documentation and all the STL available. If you need the STL I have modified for the A20, please let me know in the comments. I highly recommend to print all the parts in ABS or ASA to increase the resistance on heat and UV. Let's start and take this baby apart. Loose or remove the 3 wheels from the rail. From the side of the rail, loose the belt. Disconnect both ends of the belts from the tool head. Remove the tool head from the rail. Remove all the cables from the back of the tool head. And finally, remove the back plate from the tool head. This is the only part we need in the new tool head configuration. It's time now to assemble the tool head. Let's start from screw together the metal plate with the redesigned back plate from the Dragon burner. Let's insert the central fan, which is the smallest of the three. Remember the cable towards the top. Time to solder the NeoPixel. I do this off camera, but with the tools supplied, it should be easy enough to cut to length the first two and solder the right polarity on the LED. Once the first two are done, we can insert them into the support. Careful, because the two small legs are very delicate. I'll locate this in the bottom of the front under the fan we inserted earlier. Insert the left-hand side fan. Run the LED cables over the fan just installed. Now the LED cable needs to run inside a small hole in both parts of the hot end mount before you solder the third LED. Position now the LED in the casing. The transparent part will fit in the top inner part of the tool head. The LED casing will lock the transparent in place. At this point, we can insert the hot end mount, small part first, big part second. Let's leave them loose for now. So far, so good. Now let's insert the hot end into the mount. Once again, careful on the cables, clip the hot end in place. Now you will need very small cable ties. Insert the cable ties on the tool side of the tool head and gently start to organize the cables. Keep enough length for changing direction if you need it later. Assembly of the extruder. Starting from the daughter board, fix the 3 screws and spacers. Then the board on the back of the support. Screw the support with 2 spacers onto the extruder. Put now the 2 parts together. Remember that the Teflon tube from the hot end need to be perfectly aligned with the end of the internal gears from the extruder. Fix the extruder with 2 screws. If you require more information on this, please write in the comments. Connect all the cables in the best, neat and organized way possible. Screw the lock on the back of the hot end. Tidy all the cables as best as you can and pull all the cable ties such that they will be nice and neat. Then you can at this point cut the ends of the cable ties . You can now complete the assembly with the back plate, or probably better, you can mount the back plate on the printer first and then the tool head, whatever is easy for you. Let's add the bed sensor. Put the cable ties in the holes, but don't tie them up too much yet. Connect the cables on the board and tie this cable up with all the others. And we completed the build. I hope you're enjoying the video so far and you found the content interesting, and therefore if you do so, please click the subscribe button and on the bell next to it so that you can get all the new video that I will publish in the future. I decided to cut in 2 different parts this video. It was getting far too long. Many details, many different things to do. You will see in part 2 that the testing as well, it will be very interesting, and it will take some time to get to the point on understand where the capability of the new upgraded machines are. I hope you're enjoying this first part, and I'm sure that you will enjoy the second part even more. Thank you for watching for now, and I'll see you very soon. Thank you.